Hi everyone. In this section, we're going to work on multiplying and dividing radicals again. So this should feel really similar to when we did it with constants earlier, but we will have to sort out what happens to variables along the way. I think in some ways it's actually easier, kind of like with extracting roots, because the variable just tells you really plainly what its power is, whereas with numbers you have to think about what their factors are and look for perfect squares or perfect cubes. Um, but it does force us to think about the power in a different way than we think about the coefficient, and that can get a little confusing. So I would say we have our usual tricks. We can combine radicals when we're multiplying or dividing. We can split radicals when we're multiplying and dividing. So a lot of the work on these is going to continue to be just the simplification of the radical. So for example, the very first one, and again, my pen is turned off. I don't know why it keeps doing this. Okay. You could extract roots first, but I would say to avoid having to do it multiple times, I'm just going to do the multiplication first. So we can combine the two roots across multiplication. And we can say that that's a 60x to the fourth. And then our goal is just to simplify that root to remove as many perfect squares as we can. So x to the fourth is already a perfect square, so that one's going to be pretty nice and easy to deal with. The 60, let's see, that's 4 times 15. Actually, that might be about all I can get out of it. So it looks like I have a factor of 4. Or if you want to go further, it's 2 times 2 times 3 times 5. So the only perfect square I'm going to get out of that is a 2 squared. So let's separate off the 4 and the x to the fourth. And you can put them together or separate. How you show this work is really up to you. But do try to show me at least a little bit of what's happening. I don't know why I made that giant root. The only thing that we didn't get was the 3 times 5. So this is just going to be root 15 that we're stuck with at the end. Okay, so the square root of 4 is going to become a 2. The square root of x to the fourth is x squared. Again, multiple ways to think about that. My favorite is to say, okay, that's x to the fourth raised to the 1/2 power. So 4 times 1/2 is 2. You could also say, okay, x to the fourth is the same as x squared squared. And then the second, one of those two second powers will cancel the square root. There's others as well. So however you're thinking about that, but basically taking the square root of something with a power cuts the power in half. So when we're all done, my final answer is going to be 2x squared root 15. Okay, let's try another one. We'll work through a couple of these. Number 2. Same idea, it's just cube roots instead of square roots, and I know that that's been making it a little bit trickier for people, so we'll just work through this carefully. Remember, the difference is just that to extract a root, we have to look for a perfect cube instead of a perfect square. So I'm going to first combine them. Cube root of x to the fifth times 4x squared, which is the same thing as cube root of 4x to the 7. So I can't do anything with the 4. The factors of 4 are 2 and 2. If I don't get 3 of the same factor, I don't have a perfect cube. But I can with x to the 7. I can split off, and there's more than one way to do it. So you could split off x cubes if you would like. And we can say, okay, I'm going to separate out an x cubed and an x cubed, and I'm going to be stuck with the 4 and that lonely x. And this is a cube root as well. You don't have to split off x cubes. Really, you just need a perfect a multiple of 3 as your power to get a perfect cube. But if that's helpful, you can do that at first. My only concern would be if we have x to the 39, that's going to be a lot of x cubes to write. So at some point, try thinking about that divisible by 3. And really, that's the same thing we talked about up above. A third root is the same as raising to a 1/3 power. So as long as you split out a multiple of 3, that's going to work out nicely. So from this, I'm going to get an x and an x, which makes x squared cube root 4x. So if we wanted to do this all at once with an x to the 6th, again, you would just look for a multiple of 3, and then when you cube root that, you would have x to the 6th to the 1/3, which would take you straight to the x squared. Okay, next one, I think we'll do 4 of these, and then I'll split my video up. We have to be really careful about this. We can't just mush those roots together because one is a square root and one is a cube root. So that's not going to work for us. What we can do is convert the radicals to fractional powers. So square root of x is x to the 1/2. And the cube root of x squared is x to the 3, nope, I'm writing it upside down, 2/3, which wishful thinking, that would have made really nice addition. And we can add those exponents. So a lot of times when I'm trying to simplify a radical, I don't switch to exponent form because the simplification rules are sometimes a little bit different, what we want to do. But in this problem, I don't really have much choice. So I go ahead and I add exponents, and I'm trying to do 1/2 plus 2/3. So my common denominator is going to be 6. 2/2. Okay, so we have 3/6 plus 4/6, which is 7/6. And then since I was trying to simplify radicals, I'm just going to go one extra step here and rewrite it as the 6th root of x to the 7. So I think that's an interesting one because looking at it, it kind of feels like you can't do anything. But using the power representation, you can actually do a bit. But really, my big point with that one was to make sure you're aware that you can't just mush roots together unless they're the same root. You can't just say that what we started with there is any root of x cubed. It doesn't work. Okay, let's do one more, this kind of messy one. I haven't switched colors, so let's do that. So this is my number 4. So I'm going to do my usual where I mush the roots together. They're both square roots, so that should be fine. I don't think I actually want to figure out what 15 times 21 is. I think that's going to make my life harder. I'm going to keep them split up so that I can think about factors instead. But I am going to rearrange a little. So I'm going to put the constants up at the front. If I multiply x to the 8 by x to the 7, I'm not writing out every step on this one because I'm hoping you guys are working towards getting comfortable not writing every single one. So x to the 8 times x to the 7, you add powers, and that's x to the 15. Y to the 5th times y cubed, again add powers, and that's y to the 8. So y to the 8th is already a perfect square. It's divisible by 2. X to the 15 is not, so I am going to split off 14 of those x's, which is x to the 7th squared, so that's going to be a perfect square. And then with the numbers, here's what I was saying. You can multiply them together. It's not the end of the world, but it seems like extra work in this problem since it's not just easy. What I really want to do is get everything factored. And what I'm seeing is that I do have a pair of 3's. So I'm going to separate off a 9. And I'm going to separate off an x to the 14, and I'm going to separate off a y to the 8th, and I'm going to be left with, let's see, a 5 times 7, so a 35, and 1x. Everything else is accounted for. So just make sure you don't lose things. It can be easy to lose track of pieces if you're not careful. So these are the things that we extracted out, which simplifies a bit. Square root of 9 is 3. Square root of x to the 14 is x to the 7. Again, Maya's favorite way to do that would just be to think about that as square root is a 1/2 power. and 1/2 of 14 is 7. So it's a little weird because the coefficients you actually want 3 squared, right? You want 9 or 16 or 25. The powers, you're up a level now. So you're not you're not square rooting the power. Square rooting something with a power is the same as dividing the power by 2. Square root of y to the 8th, it's y to the 4, and then nothing to be done with root 35x. So that's my most simplified answer. Okay, thanks for watching.